There are trillions of star and planetary systems in the universe similar to our solar system. Most of these systems are internally harmonious, just like ours. If you ask people who are not very interested in space whether a starless planet can exist, you will most likely get the answer that planets must orbit a star like the Sun. But is that really the case? Does a planet necessarily have to be bound to a star? And if not, is there any possibility of life on a starless planet? Today we are going to explore this topic in depth together. If you enjoy this type of content, don't forget to like the video, subscribe to support me, and leave a comment with new video ideas. Now if you're ready, let's begin. First of all, as we mentioned at the beginning, when people think about the universe, the image that comes to mind is quite classical: a star at the center, planets orbiting it in an orderly system, and moons orbiting those planets. The reason this idea is so widespread is, of course, our own solar system. In the earlier stages of humanity's space exploration history, this idea was strongly supported. However, modern astronomy presents us with very different results. Compared to the past, these results are much more chaotic, yet also far more fascinating. According to modern astronomy, a planet does not have to be bound to any star. In fact, scientists believe that there are countless planets wandering freely through the universe. To understand these rogue planets, we first need to understand how planets form. Generally, planets are formed from the gas and dust disk left over during the formation of a star. This structure is called a protoplanetary disk. Within this disk, small particles interact and collide with each other. Over time, these particles stick together, grow larger, and eventually form planets. Of course, this process is quite turbulent and far more chaotic than we might imagine. In a newly formed system, especially among large gas giants, strong gravitational interactions occur. As a result of these interactions, some planets cannot maintain stable orbits. Like a stone shot from a slingshot, a planet can be ejected out of its system. It gains energy from the gravitational influence of another planet or star, accelerates, and eventually escapes completely from the star it was once bound to. At that point, the planet becomes a rogue world, wandering alone in the vast universe. From here on, Newton's law of universal gravitation comes into play. The gravitational force between two objects depends on their masses and the distance between them. In other words, if a planet gains enough energy, it can overcome the gravitational pull of its star and break free. And this is not just a theoretical possibility. Observations show that such planets truly exist, and in fact, they may be far more common than we once thought. Some studies even suggest that in the Milky Way, there could be more rogue planets than stars. This possibility indicates that lonely planets in the universe are not rare exceptions, but rather a widespread phenomenon. At this point, things actually become a bit more complicated. So far, I've explained how a planet that forms around a star can later escape that star's influence and become an independent rogue planet. But what if a planet formed without any star around it in the first place? This idea might sound crazy, but it is actually widely accepted among scientists. Here's how. When massive molecular gas clouds collapse under their own gravity, they form celestial objects. However, if these objects fail to gain enough mass, they cannot reach the threshold required to become a star. Because of this, a separate classification exists for such bodies. These failed stars are generally referred to as substellar objects or planet-like bodies. In other words, they may not be specific planets like Earth or Mars, but they also cannot be classified as stars. That's why they are given this distinct category. Their formation process is actually very similar to that of stars, but the outcome is different. As a result, these objects are born directly into darkness and never orbit a star at any point in their existence. So what do you think the conditions on a starless planet would be like? Would it be extremely cold or incredibly hot? Or contrary to expectations, could it somehow have conditions suitable for life? First of all, we need to understand that stars are not just central points for planets, they are also their primary source of energy. Without a star, planets are like a car without fuel. The electromagnetic radiation coming from a star determines a planet's surface temperature, shapes the dynamics of its atmosphere, and most importantly, makes the existence of liquid water possible. For this reason, the first and most obvious characteristic of a rogue starless planet would be extreme cold. The surface temperatures of such planets can drop to hundreds of degrees below zero, and even if they have an atmosphere, it may eventually condense, collapse onto the surface, and form layers of frozen gases. However, don't get this wrong. A completely frozen planet does not necessarily mean a dead planet. If the interior of the planet is active, especially if there is a heat source generated by the decay of radioactive elements, then the planet can remain geologically active from within. Thanks to this internal heat, temperatures beneath the surface layers can be significantly higher. If the planet is large enough, there could be a thick layer of ice on the surface, while beneath it there are vast liquid water oceans extending for kilometers. This is similar to what we observe on moons like Europa and Enceladus. This phenomenon is known as a subsurface ocean. In addition, although it is still largely theoretical, some rogue planets are thought to have thick atmospheres. If these atmospheres are rich in hydrogen, they can create a strong greenhouse effect, trapping the planet's internal heat. As a result, even without a star or incoming stellar energy, temperatures on the surface or near surface regions could be much higher than expected. In short, the planet can protect itself through its atmosphere and retain its own heat. When discussing the possibility of life on such planets, they are often labeled as dead worlds, leading many to assume that the chances of life are zero. However, as I mentioned earlier, the idea that a frozen planet must be lifeless is now considered outdated in modern astrobiology. When we break down the essential conditions required for life, we see that a star only provides part of what is needed. I don't want to be misunderstood. What a star provides is extremely important and is indeed one of the fundamental building blocks of life. However, the absence of a star does not reduce the possibility of life on a planet to zero. As you may know, life depends on three main critical factors: liquid water, an energy source, and a suitable environment where complex chemical reactions can occur. According to the traditional model, this trio is supplied by the light and heat from a star. But on a starless planet, these same requirements can be met through entirely different mechanisms. First of all, when it comes to energy, one of the most important biological processes on Earth, photosynthesis, is directly dependent on sunlight. However, photosynthesis is not the only way life can produce energy. In the depths of the oceans, kilometers below the surface, there are organisms living in complete darkness that obtain their energy from chemical reactions. This process is called chemosynthesis, and it occurs through the oxidation of substances such as hydrogen sulfide, methane, and iron. These types of ecosystems are most commonly found around hydrothermal vents on Earth. The temperature, pressure, and chemical richness in these regions create a perfect environment for life, resulting in a completely different form of life that exists without any dependence on sunlight. This situation actually shows us that life on a starless planet, that is, a planet without a star, is theoretically possible. If such a planet has liquid water beneath its crust, and if this water interacts with the rocky core to produce chemical energy, then the emergence of microbial life becomes highly likely. In particular, geochemical processes known as serpentinization produce hydrogen gas through the interaction of water and rocks. This hydrogen serves as an excellent energy source for microorganisms. In other words, a biosphere can form even without starlight. Another important energy source is tidal effects. If a rogue planet has a large moon orbiting it, the gravitational interaction between these two bodies creates a continuous cycle of compression and relaxation. This process is called tidal heating, and it can generate significant amounts of heat within the interior of the planet or its moon. Therefore, even if a planet does not have a star, it can still generate heat through tidal forces as long as it has a sufficiently large companion to interact with gravitationally. The subsurface oceans observed on moons like Europa and Enceladus are prime examples of this mechanism. These examples once again show that liquid water can exist for long periods entirely independent of starlight. The effect of greenhouse gases is actually even more critical for such rogue planets. As mentioned earlier, a thick atmosphere can trap heat through the greenhouse effect, potentially turning the planet into a habitable world. Although this may sound utopian, it is completely consistent with the laws of physics. However, it is important to remember that while microbial life may emerge relatively easily under these conditions, the development of complex life forms is much more difficult, especially when it comes to intelligent life. The probability becomes extremely low. So on such a planet, it is far more likely that microbial life would exist, as these organisms require far less energy compared to complex life forms like us. Of course, the existence of intelligent life is not impossible. It is not zero, as often portrayed in fictional scenarios, but it remains highly unlikely. The scenario in which our own Earth becomes a rogue planet by breaking away from the Sun is also a widely discussed topic. The Sun provides almost all of the energy that reaches Earth. This energy flow is approximately 1,361 watts per square meter and is known as the solar constant. Earth's energy balance depends on the equilibrium between incoming solar radiation and the infrared radiation emitted back into space. If one day Earth were to suddenly drift away from the Sun, this energy input would instantly drop to zero. This would completely disrupt the planet's energy balance. Although the last rays of sunlight would continue to reach Earth for about 8 minutes after separation, this is an extremely short time on a cosmic scale. Within the first few days after leaving the Sun, surface temperatures would begin to drop rapidly. According to estimates, the average surface temperature of Earth would fall below 0 degrees Celsius within about a week. Within a year, it could drop to around -70 degrees Celsius. As time goes on, the planet planet would continue to lose heat, and in the long term, temperatures could fall as low as -200 degrees Celsius. However, this process would not be linear or perfectly uniform, because Earth's atmosphere and oceans would initially act as heat reservoirs. In particular, the oceans, due to their high specific heat capacity, can retain heat for a long time. For this reason, the freezing process would begin on land. Ice formation would accelerate in the polar regions, then spread to mid-latitudes, and finally reach the equatorial regions. Unfortunately, the oceans would not survive for long either. Within a few years, the surface of the oceans would be completely covered by a thick layer of ice, which could eventually reach kilometers in thickness. The critical point, however, is that, as mentioned earlier, if the planet's interior remains active and retains its heat, the deeper layers of the oceans could still exist as liquid water. Geothermal heat in particular could keep the ocean floor at a certain temperature for a very long time. In this way, while the surface of Earth turns into a frozen ice world, its interior could remain relatively warmer and still capable of supporting liquid water. Our atmosphere would also be heavily affected by this sudden separation. As temperatures drop, atmospheric gases would begin to condense. Water vapor would first fall to the surface as snow and ice, followed by carbon dioxide, freezing into dry ice. Over the long term, a significant portion of the atmosphere would collapse onto the surface, leading to a dramatic decrease in atmospheric pressure. This would make surface conditions extremely hostile for life. Plants deprived of sunlight would no longer be able to perform photosynthesis. Combined with the extreme cold, plant life would rapidly die off. Once plants disappear, oxygen levels would also begin to decline significantly, severely disrupting the food chain. Most animals would not survive this sudden change, and only microorganisms in the deep oceans and certain extremophiles would be able to continue existing. The fate of humanity, on the other hand, would depend entirely on technology. If preparations were made in advance, and if there were underground shelters equipped with sufficient food, animal resources, and energy supplies, humanity might be able to survive for some time. However, as mentioned, this would entirely depend on the level of technological advancement at that point in time. In the very long term, Earth would become a true rogue planet, its surface covered in ice, its atmosphere largely collapsed, and its environment dark and silent. Yet, in a surprising twist, if the planet manages to survive for millions of years, it could potentially be captured by the gravity of another star and enter a new orbit. In such a case, the continuation of this scenario would become even more fascinating. But that is a topic for another video. And that's it, my dear friends. Rogue planets are not the lifeless, dead worlds with zero chance of life that we once thought they were. Perhaps as humanity, we will discover our very first extraterrestrial life on one of these wandering planets. If you enjoyed the video, don't forget to like it, subscribe to my channel if you enjoy this kind of content, and leave a comment with new video ideas. Until we meet again in the next video, take care of yourselves. Goodbye.